Go.
Okay, right. All we're going to do year 11 is a quick video just to remind you of the true awesomeness of velocity time graphs, okay? So here we've got a velocity time graph, and there are some basic bits of information we can take from this. Imagine we've got a car, and we can see from our velocity time graph that that car is travelling at a constant velocity of 6 metres per second. And we can read that off the y-axis. So that's one piece of information. We can also see that that car, for the duration of this graph at least, is travelling at 6 metres per second for 10 seconds. So now that's two pieces of information that we've got about the car. But the brilliant thing about velocity time graphs is we can then calculate other pieces of information. So for example, from a previous lesson, you will remember that if you want to calculate how far an object has travelled, all you need to know is the velocity that it's travelling at and how long it travelled at that velocity. And if we have those two bits of information, we can multiply the velocity times the time. So if we do that for this particular velocity time graph, we can see that it travelled at a velocity of 6 metres per second, and it did that for a total of 10 seconds. So that tells us that this car travelled a total of 60 metres. But that's not all, because if you look carefully at this graph, you'll see that what we've actually done is we have calculated the area of that rectangle, the rectangle made by the graph and the line that represents the object. So what we would say in physics is that area under the line in a velocity time graph represents the distance that an object has travelled. 6 multiplied by 10. But it gets even better than that. If I go to the next slide, I've got a slightly more complicated graph. So we can see on this one, we've now got an object that is accelerating at first. We can see its velocity is changing over time, and then it starts to travel at a constant velocity. Now, for this section of the graph, it's dead easy, isn't it? It's just like the previous one that I showed you. If we wanted to calculate how far the object has travelled during this time, all we need to know is the velocity of the object, which is 5 metres per second. And we want to know how long it was travelling at 5 metres per second, which is 5, 6, 7, 8, 9, 10, so that's for 5 seconds. And so we know that if we work out the area of this square, that's the distance the object travelled, which is 25 metres. But then we got here, this bit where it's accelerating. That seems at first a little bit more tricky. How do you calculate how far an object goes whilst it's accelerating? Well, I'll tell you now, it's not complicated, because we still just need to calculate the area under the graph. So really all we're doing now is we're calculating the area of this triangle. And as you should know from maths, to calculate the area of a triangle, we do half times the base, which is 5 again, multiplied by the height of the triangle, which is 5. Sorry, it's not very tidy. And that works out at 12.5 metres. And so to calculate the total distance travelled by this object, we simply need to add the 25 metres, the area of the square, to 12.5 metres, the area underneath the triangle, giving us 37.5 metres as the total distance covered by this object. That's your lot.